And for that constant function, the domain of it is going to be all real numbers. So whatever values it actually plug in, the domain would be all real numbers. Any of them would be all real numbers. So even if it was f of x equals 6, the domain is still all real numbers. Now the range is just y equals 1 for this here. So if it was f of x equals 4, the range would be 4 because the y value is 4 for it. Now our linear function is just a straight line going up. So f of x equals x is a linear function. Anytime we have a line going up, going down, just a straight line, unlike a constant function, which is straight across, it is going to be linear. It's either going to be going up or going down. It will not be flat. The domain for this is going to be all real numbers in the range. This is one of the few ones that the range will also be all real numbers. If it's a linear function, the domain and range will always be all real numbers for either one. Our absolute value function will look like a V. Any and all absolute value functions will always look like a V shape. And the domain for it, the domain for the parent function will be all real numbers. And the range is going to be y is greater than or equal to 0. That's what it's going to be for the parent function every single time. Now the different transformations we will have will change how it looks and what the domain or the range is. But the domain, again, for all of these here, will always be all real numbers. For this or any of the transformation, however we change it, the domain will stay all real numbers. So no matter what it is, the domain is always all real numbers. And our last one we look at is quadratics. Our quadratic is a U-shaped graph. It'll look like a U. And the domain is going to be all real numbers. The range here is y is greater than 0. So we're talking about the y values. Again, for the range on any of these here, we're talking about the y values. So here it's just 1. That's all it is. All real numbers. Now the only places that the absolute value function is above the x-axis. So that's where y is greater than or equal to 0. Same for this here. The function is only above the x-axis. So it's where the values of y are greater than or equal to 0. Okay? So even on the homework or anywhere this is asked, for the parent function, these will always be true. Whenever it asks about the domain or range of the parent functions, this is the information. You have it every single time. Any questions on this so far? Okay, I want you to turn your note sheet all the way over because we're going to put some additional information on the back about these transformations. There are several types of transformations. Now our linear, quadratic, and absolute value function. So our linear function, we're going to call f of x equals ax plus k. Our quadratic, f of x equals a, parentheses, x minus h squared plus k. And our absolute value, f of x equals a, absolute value of x minus h plus k. These are our three main types that we'll have. Now these are what we call the general equations, standard equations. And the different values that we have for a, h, and k will tell us how the function is going to change. Now the domain for all three of these is still going to be all real numbers. It's always going to be all real numbers. We can plug any value we want into it. Now the first one we have is a translation up slash down. If we're going to move these from the parent, we're going to move it up or down, one of the two. Translation up or down is k. The value of k. Whatever that value of k is going to be our translation up or down. So for any of these here, whatever this value of k is going to tell us if it's going to move the function up or it's going to move the function down. So if we had a k value of positive 4, which direction would it move? Would it move up or down? Positive 4 would be up. Positive 4 would be up. Negative 4 would be down. So if we're subtracting 4, it'd move it down. If we're adding 4, it would move it up. So this would look something like f of x. So x squared minus 4 would move it down 4. Because we're subtracting 4, we have negative 4. And if it's plus 4, it would go up. And that works with linear, quadratic, or absolute. Any of those, it's going to work the same. It's going to look a little bit different with constant, the constant function, because, well, the constant function is just what? 1, right? Because if we said f of x equals 1 plus 4, I wouldn't really leave it as 1 plus 4. I would write it as 5. So it's a little bit different with the constant function. Are we good with up and down? Up and down is pretty straightforward. If it's plus, it's moving up. If it's negative, it's moving down. Now I'm going to erase this so that I have room. Below that, we're going to do, we have another translation. But this one is left slash right is our h value. The value of h tells us if the function moves to the left or the right. So what's inside the parentheses here? Tells us if it moves to the left or to the right. So looking at that one there, the absolute value of x minus 2. So obviously it's moving 2 units to the left or right, yes? Or is it 2 units to the left or is it 2 units to the right? It's to the right. It is 2 units to the right. Because, again, look at the basic function. X minus h. What is the value of h for this here? 2. Is it positive or negative? It's positive because the negative sign is in our function, isn't it? Because here it's x minus h. The value of h is positive 2. Really, one way to think about it is it's really whatever opposite of what you think it is. Because if it's plus, we're moving to the left. If it's negative, we're moving to the right. Because like this here, we're moving 2 to the left. But really what this is saying that we have is that it's really saying that this is x minus negative 2. We don't leave a negative in the negative. We rewrite it as positive. So if it's plus 2, we're moving to the left. If it's minus 2, we're moving to the right. So whatever's inside parentheses kind of lies to us. It's the opposite of what we think. Inside parentheses, inside absolute values is the opposite of what we think it is. Questions on that there? And again, we're going to be looking at functions and kind of describing this here in a minute, in a little bit. So any questions on any of this here so far? So far we've gone over what? Translations up and down and left and right. And left and right is kind of opposite of what we think it is. Any questions on any of our translations so far? Okay, it'll make more sense once we start looking at some graphs. The next one we have is vertical stretch slash shrink. If A is greater than 1, it's a vertical stretch. If A is greater than 1, it's a vertical stretch. If 0 is less than A is less than 1, we have a vertical shrink. So if A is greater than 1, it's not too bad. It's any number bigger than 1 is a vertical stretch. If it's between 0 and 1, so we have a fraction, a decimal, something less than 1 but greater than 0, it is a vertical shrink. And what that means is the y values. If it's a stretch, it means it's increasing faster. It's going to be going up faster than the parent function. If it's between 0 and 1, it's wider. The graph will be wider than the parent function. And this is always going to come in front of our term. So here, here, here. This value of A in front tells us if it's a vertical stretch or vertical shrink. So when we look at it, is it a whole number greater than 1? If yes, it's a vertical stretch. If it's between 0 and 1, it's a vertical shrink. Questions on this here? We good so far? We have one more. Last one we have is a reflection. A is negative. Reflection across the x-axis. If A is negative, it's a reflection across the x-axis. So when we look at vertical stretch and shrink, we don't care about the sign. The sign, if A is negative, it's a reflection. It doesn't deal anything with our vertical stretch or shrink. I'll read this to you here in a second. So if x is negative inside the parentheses or absolute value, then it's a reflection across the y-axis. This bottom one, what it's saying is something like f of x equals parentheses negative x squared. This is what that second one's talking about. Or f of x equals the absolute value of negative x. So if the negative is inside the absolute values or the parentheses, so if the x inside those parentheses or absolute values is negative, it's a reflection across the y. It's a reflection across the y. If x is negative inside the parentheses or absolute values, look something like this here. I'll write this down below. For this last one. One of these here, then it's a reflection across the y-axis. Now for this here, those functions that I wrote up there, if you were to graph them, you wouldn't see a difference because they end up graphing onto themselves. Any questions on any of these so far? You all have these down? Yes? Okay. You're still writing, Cabry? Okay. So there are other, if you've noticed already in the notes, there's more graphs and stuff we'll look at, and it's faded, yes? The stuff on there is pretty faded all the way through. Have you ever heard the saying, don't make a copy of a copy? This is what happens. I made a copy from the slides and printed it down. The printer in the main office won't copy it, so I copied that copy and then made a copy from that. It deteriorates as you copy. Yep. Because the main printer, do you see how this is taped on? Considers it two pieces of paper and thinks it's a jam. So it won't copy it. But what we're going to do for the rest of the day, this hour, is look at these graphs. I want you to actually see what is going on here, okay? So this here is an, what type of function? What is its parent? It's a, what? Linear. It is a line. So one of the things we talked about with the linear function is that we can move it up or down. So how far do we want to move this one up? 3. So x plus 3, our value of k here is 3. And if you notice, it moved it up 3 spots across the entire function. Yes? Now, we could do x minus 3 and see how it moves it down 3. Now, we don't really talk about left and right with linear functions. We mainly talk with up and down. Questions on this here? Now, the other thing we looked at was vertical stretch and vertical shrink. So when we say it's a stretch, the value of A is what? Greater than 1. So let's stick with 3. So if I said 3, vertical stretch of 3, so this is our parent function. We'll look at that. It's increasing faster. It's increasing faster by a scale of 3. It has a vertical stretch of 3. Now, vertical shrink is a fraction. So we can say 1 over 3. And look at how it moves along the y. The values of y for this one here, that's 3x, are going up faster than the parent, and the one in green is going slower. So a vertical shrink is telling us that it's moving slower along the y-axis. And it's moving at a slower pace of 1/3. It has a vertical shrink of 1/3. Questions on this here? Now, there isn't really one for a vertical or a horizontal, a reflection across the y, but we can have a reflection across the x. So every point here is now below. Since this point is below, it's now above the x-axis. It flipped. Now, it doesn't seem too much and doesn't do too much for a linear function, but if we look at a quadratic, so we're talking about x squared let's see. If I say negative x squared, we can now see that it's mirrored below, yes? So that this is our parent function, x squared. The reflection across the x-axis is now below it. Now, I said the reflection across the y-axis won't be too visible on a quadratic here, as if we do it inside. The red color just changes colors, doesn't it? Because it's not actually So if I move it one away from the center so that we have some points that way, when we reflect something across this axis, this point will go here. That point's not going to change, but this one is going to be over here. It's going to change over. So we look at it now, we can see that it is reflecting across that y-axis. Because when it's on the axis, just x squared, the points are mirroring onto themselves. It's going back to where they were. So we're starting to see some of these transformations. Yes? And this is how they work, and it's really just describing these functions and seeing them. Because x minus 1 squared is telling me I have 1 unit to the right. This here, the parentheses, negative x minus 1 squared, I have a reflection across the x and 1 unit to the right. So every point is moving, and we're describing how they move. Okay? Now what we're going to do tomorrow is we're going to finish that worksheet, going through the different ones and explaining those different transformations, because that's what's going to be a part of the assignment. Okay? AJ, did it log you in, or did you shut it before?